Yeah, hi, good evening, everyone. Good evening and warm welcome to CAT Mojos. So, if you are preparing for CAT 22 or CAT 23, here we are. So, we have started a new course and we do it in about 3 to 4 stages. We first start with the foundation as we are doing now. So, then we will move on to the intermediate stage of our learning. Then we will go on to the advanced stage of our learning and then we will finish it by doing it about the reinforcement, right? So this is the kind of 4 stages is what we are trying to do out here. Well, all right. So on this note, I welcome all of you out here into this particular lecture. So I guess all of you had a good weekend and here we continue with the first module. What we have done is we divided this into 4 modules. So that is, we said we'll start off with the numbers, then we will do a little bit of algebra, we'll do a little bit of arithmetic, then we'll do a little bit of geometry. So that's how we do kind of foundation across these 4 courses under Quant. Meanwhile, as we try and finish the foundation, we will also start off with the LRs and DIs, right? Because for the DI, once the quantitative foundation is good, it would not be very difficult to deal with the DIs. I mean, like the transition would be smoother. Right, so there we go. So that's a little bit about the course overview and the background as to how we are looking at this particular course. Yes, before we start off, so here I am. So my credentials. So I have worked in test prep industry for the last 14 years. That is since 2007. Yes, I worked in various capacities in various different organizations. You can see it's on this particular deck. Yeah, over that period of time, I did develop some good skills to train the students in the space of QA, LR, and D. Although I enjoy mentoring the students in the space of the counseling, how they have to prep their plan, their study calendar, and their interview, and so on, and making the right selection of the school. Right, that's about the counseling side of my career. Right, so how do you reach out to me? You can use one of these Telegram channels and you can post your concerns, you can post your doubts, post any of your small have. Yeah, that's how you can reach out to me and we can have the dialogue right to this particular Telegram channel. Not only there is a fair bit of peer interaction as well. There are many other students. If you have certain concerns, yes, you can also interact. That's briefly about how we can work out together. Great. So that sets us. So what we were doing in the previous few episodes before that. So there are certain doubts. If you have some doubts, there is a doubt platform on the Unacademy. There is a feature where you can ask up to 3 doubts in one single go. That if you can do it in 2 ways. Either you can use your desktop or a laptop, and you can do this. You can submit your doubts, or it can be through your learners app. Use the app. Through the app also you can post your doubts, right? Yeah, so if you have not updated your app, probably from the Play Store, you may have to update your app again so that you will find these features, right? So because it's an application based, if your app was downloaded quite some time back and if you see that, hey, where is this doubt feature, it is not featuring on my dashboard, it should be featuring on your dashboard. Just in case you don't see it, just refresh your app, you should be able to see it, right? So you refresh your app. I'm sure, all right. No, so an app, or it can be on the website, in the sense like on your desktop app also you can see. Fair enough. That's briefly about how you can ask your doubts, because it's not that you should use only the Telegram channels to ask your doubts. You can ask this as well. Some of them will get back to you, and you can also use the preference of the language, right? Would you like to answer this in Hindi, or would you like the answer in English, right? Whereas the doubt forum has that preference. Fair enough. There we go. So that's a little bit about how you can understand about the doubts. So today we are doing the factors learning. What we have done previous week was we tried and take a quick look at the LCM, HCF. It's not over yet. I will come back to it once again because we will be doing the LCM and HCF models. Certainly, yes, but then yeah, we kind of at least started off by understanding the LCM, HCF. We also spent little quick time about the divisibility algorithm and some of the divisibility rules, right? And we'll come back to them once again at some stage, or if not at the intermediate stage, certainly, right? So but before, we'll also kind of like quickly take a look at certain things that we have done in terms of factors, right? What we have done in terms of factors. Technically, factors as a word would be introduced to students at the age of 10 years. That's in the class 4, technically in class 4 or class 5 based on the boards. Generally, more often than not, it is the class 4 when students hear this word factors for the first time, right? Factors for the first time. And all these numbers what I've listed is the 4th standard students. They look at all these particular numbers in the 4th standard and they will actually list out all these factors. Listing of the factors is taught in the 4th standard. You may wonder why we are doing it now. Okay, if it is a 4th standard listing of the factors, yeah, it is well beyond it. But then, yeah, I have some 2-3 points to make. From the CAT perspective, there are 2-3 points that we have to remember from that high school, from that primary school to high school, what we have learned a little bit about the factors. And that's what we are going to look today. Right, let's take a look at this 18. Let's take a look at this 18. How do we write the factors? I will not go at the 4th standard level. So 4th standard to high school, what are the different things that we kind of learned? I will put that together to understand this preparation. Right, yeah. 18. So we know that already. You must recall that half of the factors come before the root of 18, half of the factors come after the root of 18, right? It is always true, which means if I have a number n, half of the factors, if I write all the number series, half of the factors would come before root n and half of the factors come after root n. That itself is a very powerful statement, right? Yeah. There are a good number of applications built on this, which we will do at the intermediate stage. But today it is very important to know that half of the factors lie before the root n, square root of n, and half of the factors lie after the square root of n. It's a very powerful statement. What I meant here is this: what is square root of 8? Means I will first find out what is square root of 8. Square root of 8 is something like 4 point something. Let me for the time being write it as 4.x. You may say that sir, it is 4.3, 4.2. Yeah, that's all right. So let's park it aside. Let's for the time being call it as 4 point something because it lies between 4 and 5. All right, so this is 4.x. So what I'm trying to say is list down all the numbers before this, that is 1, 2, 3, 4, and let's see the factors. That 1 divide 18, yes, therefore 1 is a factor. Does 2 divide 18? Yes, therefore 2 is a factor. Does 3 divide 18? Yes, 3 is a factor. Does 4 divide 18? No, therefore 4 is not a factor. That's a meaning there. You may wonder, why did you stop at 4? Why didn't you write 5 here? Because I told you that half of the factors come, the number of factors before the root of 18. What is this root for 4.x? This is root 18, right? Number of factors before the root of 18 is same as the number of factors after the root of 18. The moment you take root of 18, you'll be left with only 4 integral values, 4 natural numbers, out of which 3 of them are factors. What it means to us, the remaining 3 will come on the other side. Now you may wonder how the remaining 3 will be. Very simple. 18 into 1 is 18. So therefore put the other side as 18. That is another factor, right? Okay, so now 18 into 2, already 9 into 2 is 18, right? Therefore already you say that the other side would be 9. Other side is going to be 9. 9 would be another factor, right? Then 3 into 6 is going to be 18. Therefore the other side it is going to be 6. Now these are the only 3 factors. What I meant is, hey, after 4.x, which means there is 5, 6, 7, 8, 9, like this up to 18. Only 3 numbers get shortlisted. 18 is a factor, 9 is a factor, 6 is a factor, others are not factor. This is an important statement. What is an important statement? Number of factors that come before root of the number is same as the number of factors that come after the root of this particular number, right? So this is something that you probably may have to remember it out here. Okay, let me do one more to illustrate this particular point. And hence 18 has how many factors? 6 factors. If you ask me how many factors are there for 18, it has 6 factors. Okay, is this what we do? No. So I'm just proving out a statement to you that number of factors before the root of the number is same as the number of factors after the root of the number. Number of factors more than the root of the number. This is the point I'm trying to illustrate. Let's take another example, 72. Okay, hey, what is root 72 look like? Root of 72 look like? Root of 72 should be 8 point something. It lies between 8 and 9, right? 8 and 9. You may say that no sir, it is 8.4, 8.5, whatsoever it is. Let us take it as 8.x because that's another study. How to find the root of 72 is another study in itself. Let's not get into that study today. So we'll call it as 8.x, something more than 8 but less than 9. All 12, right? So okay, in the sense now you are writing 8.x. What is this 8.x? This is root 72. So now list down all the numbers before this. In the sense, in your mind you are listing it down. You don't have to necessarily write on a piece of paper. In your mind you are checking it. Yeah, what are the numbers you are checking? Does 1 divide 72? Yes. Does 2 divide? Yes. Does 3 divide 72? Yes. Does 4 divide 72? Yes, which means that becomes a factor. Does 5 divide? No. Does 6 divide? Yes. Does 7 divide? No. Does 8 divide? Yes. Right? Does 9 divide? No, you don't have to write 9 because 8.x is the halting number. Therefore, only till 8 you will understand. Okay. So therefore, you say that okay, 5 is out and 7 is out. You are now trying to say that there are 6 factors which are less than root 72, which divides 72, which implies there would be 6 more factors on the other side. Well, how do I get the remaining 6 more factors? 1 into something is equal to 72 itself, right? Therefore, what is 1 into something? 72. Okay. Then 2 into something should also be equal to 72. What is that? Alright, that is 36. Right, that's going to be 36. Similarly, 3 into something is going to be 36. What is that? 24. That's another factor. Right, 6 into something is going to be 36. What is that? 18. Okay, 8 into something, that's going to be, 4 into something is going to be 36. What is that? 18. 6 into something is going to be 36. What is that? That's going to be 12. Right, then the 8 into something is going to be 36. What is that? That's going to be 9. So this is what you are listing the other side of the factors. These are another 6 factors. Right, together you will say that 72 has 12 factors. Simply put, now listen to me very carefully. There are n factors before less than root n, and there are n more factors after root n. Together how much? Therefore together you say that together there are going to be 2n factors, because there are n factors which came before root 18, there are n factors which came after root 18. Therefore you said that there are 2n factors. 2n is equal to 6. Of course 2n is equal to 6. What about the second one? There are n factors before root of 72. There are n factors after root of 72. It cannot be n and m. You cannot say that, sir, it is n factors here and it is going to be m factors here. No, n and m will be same, right? Therefore they have to be same there, and hence you are saying that 2n is equal to 12 factors. Now let's take a look at the next one, 36. Right, when I look at 36, when you do root 36 becomes 6. Okay, that itself qualifies as a factor. However, numbers less than 6 are 1 divides, 2 divides, 3 divides, 4 divides, but 5 does not divide. Okay, then 6. Coming to the other side, 1 into 36, that's one number. 2 into something, that is 2 into 18 is 36. 3 into something, therefore 3 into 12 is 36. 4 into something, 4 into 9 is 36. Good. So you are writing another 4. Now here, look at this. There are n factors which came before the root of the number. There are n factors which came after the root of the number. And there is one more number itself, because this time the root of the number also qualified as a factor. Why did this happen? Because 36 is a perfect square. Right? When you looked at 18, it wasn't a perfect square. 72 was not a perfect square. However, so when you looked at 36, it's a perfect square. In the sense, now you are trying to say that, man, it has 9 factors. Reason being, it has 2n plus 1 factors. There are n factors which came before. There are n factors which came after the root of the number. However, the root of the number also qualifies. Therefore, it has 2n plus 1. 2n plus 1 is odd. Now coming to this, any number of the form 2n is even. Any number of the form 2n is even. Any number of the form 2n plus 1, because even plus 1 would necessarily become odd. And hence what is that we are trying to say? Okay, you want to understand it a little better, take another 100. Alright, then we will come back and summarize a little bit. Let's take a look at this 100. Okay, root 100. So therefore you would now say that root 100. Let's go to root 100. Okay, what is root 100? Root 100 is 10. That itself becomes a factor. Now list out the factors less than 10 which divides 100. 1 divides, 2 divides, 3 does not divide, 4 divides, 5 divides, 6 does not divide, 7 does not divide, 8 does not divide, 9 does not divide. You are trying to say that these are the only 4 factors which are less than 100. What about the remaining 4? From here you can generate. 1 into 100 is 100, 2 into 50 is 100, right? Similarly, 4 into 25 is 100, 5 into 20 is 100. Good. Alright, therefore you have another 4 factors on this side. So plus one more factor right in between there. And then you are trying to say that, hey, this has 2n plus 1. Why 2n? Because n factors before, n factors after, and 1 factor which is nothing but the root of the number itself. 2n plus 1. So this also has 9 factors. Right? And therefore 100 also has 9 factors. Good. So therefore, what is that we are trying to say? If the given number is a perfect square, now look at this example. 2n plus 1 is odd. 2n plus 1 is odd. If the given number is a perfect square with like 36 and 100, it would have odd number of factors. Perfect squares have odd number of factors. What if the number is not a perfect square? It has even number of factors like 18, like 72, right? They would have even number of factors. All this from your high school, right? Of course, in the primary school, you looked at this 18, you did little bit of brainstorming to write 1 is a factor, ma'am, 2 is a factor, ma'am, 3 is a factor. Different kids shouted different numbers, and that's how you learned. All right, that's how you learned, knowing that you cannot list, you don't have to think of a number greater than 18 which divides 18. Like this, you went on to think from 1, 2, 3 up to 18. Then you came to the high school, then you kind of suddenly realized that, okay, because then you learn the squares and square roots, etc., etc. By the time you come to the high school, same factors, you understand that number of factors less than root of the number is same as the number of factors more than root of the number. That's what your high school teacher said. And then they finally wanted you to remember this. If the given number is not a perfect square like 18 and 72, if the given number is not a perfect square, it would have even number of factors. If the given number is a perfect square like 36 and 100, it would have odd number of factors. All right, that is the summary they kind of wanted you to remember. Maybe some of the teachers would have gone little ahead and they would have said a little more about this. Okay, in a sense, okay, what is that little more? So like 25, right? Now take a look at the number like 25. 25 is also a perfect square. However, 25 has only 3 factors. 1 is a factor, root of 25, that is 5, is a factor, and the 25 itself is a factor. That is it. It has only 3 factors. Right, it has only 3 factors. Similarly, 49, right? 49 also has only 3 factors. 1, root 49, which is 7, and 49 itself, only 3 factors. You may wonder, why is it happening? Now comes the concept of, right? Concept of, is it a square of a composite number? If the square of a composite number, if my given number n is nothing but a square of a composite number, all right, now composite number, then it will have the composite number versus the given number is a square of a prime number. Square of a prime number. If it is a square of a prime number, this would have exactly 3 factors. It would still have odd number of factors because it's a perfect square. Perfect squares have odd number of factors. However, that number is static. It would have exactly 3 factors. However, if it is a square of a composite number, it may have just 1 factor or 5 factors or 7 factors or 9 factors, etc. But it will not have 3 factors. The square of a composite number, it will not even have 1. The square of a composite number would have minimum of 5 factors, right? Square of a composite number would have a minimum of 5 factors. However, the square of a prime number would have exactly 3 factors. Okay, let us understand this. So what is the example for this? If I were to give an example, what is the example for the first one? The example for the first one is number like 36 that I wrote here. All right, there is a 36 that I wrote here. 36 is an example. Why 36? 36 is a square of a composite number. It's a 6 square. Therefore, how many factors are there? 9 factors are there. 9 is possible because it would have minimum 5 factors, right? Minimum 5 factors, 5, 7, 9, 11, 13, etc. Okay, now same thing is true for 100 as well. Hey, what about this was 100? Yeah, 100 is nothing but square of a composite number. Therefore, this also had 9. Okay, it is coincident that both of them have 9. They can have 7, they can have 5 different numbers, right? So that's what you mean there. Okay, what about the next one? Square of a prime number. What can be an example to this? The example to this can be something like, call it now, the 25 and 49. A 25 is nothing but 5 square, right? When you wrote 25, you wrote it as a 5 square. What is that 5? A prime number, square of a prime number. Similarly, we looked at 49. What is 49? All it is nothing but a square of a prime number. So this is very clear. So 3 statements I technically made, right? Technically made here. If the number is not a perfect square, if number is not a perfect square, it would have even number of factors. Point number 1. This is one of the points. Right? Yeah. Number 2, if the number is a perfect square, it would have odd number of factors. Right? If the number is a perfect square, it would have odd number of factors. However, if the number, here we talked about 3 things. What if it is a square? Already, if the number is a square of a composite number, if it is a composite number square, so then the number of factors would be of the form 5, 7, 9, 11, etc. 5, 7, 9, 11, all this. Okay, B. All right, if the number is a square, all right, because we said perfect square, right? If it is a square of a prime number, then it would have only exactly 3 factors, right? This is what we kind of said. And more importantly, even before all this, what we discussed is the number of factors before the root of the number, like this here, n factors before root 18, number of factors less than root of the number is same as number of factors more than root of the number. Right, now these are the points that I tried to make. These are the 3 solid points I tried to make. Let's take a look at some of the exam type of questions which may come on this particular point. Yeah, if anybody is listening here, all it attentively, are you following me? Can I see some response in the chat quickly? Are you following what I'm trying to say? Right, anybody would like to quickly respond there in the chat? Take time, quickly respond there. Is it making sense what I said so far? The 3 points are clear. I'm hoping that you are keeping a pen and a book and trying to note down certain points, right? That's what we do. The entire high school will try and cover in about 1.5 months. Then we are ready for the intermediate stage, right? The foundation stage, which means whatever you learned up to high school. And when we summarize this, you already get 80 percentile in Quant, in CAT. That's a reality, right? That's a reality. And the intermediate stage will take you beyond 80 percentile in CAT. That's what the intermediate stage kind of does. Advanced stage will take you beyond 90 percentile, 95, 99, all that. And if you do proper reinforcements, sure, all right, you are very, very safe in the zone of 97 kind of percent. Great, all right. So, all right, let me continue. Let me continue on this. Let me continue. Yeah, okay, I gave the summary here. Whatever I wanted to tell, I kind of gave the summary here. And here is a simple question. Here is a simple question. Take a minute to reflect on this particular question. Take about 30 seconds maybe. Just think about this. Just think about this. How do you approach this? Please remember the CAT had 35% of the questions as theta questions, right? CAT 2021 had 35% of quant questions as theta questions. 8 out of 22 were theta questions. So you need to be mindful. You need to be mindful. That's every third question was a theta question. Hence, always learn to do the questions without answer choices. Even if there are choices, even if you use by answering using choices, try and do that question without choices, because 1 out of 3 questions is a theta question is too high a margin, right? Yeah, okay, all right. So because some people are well used to answering using the choices, the moment all right 1 out of 3 questions do not have a choice, it requires a lot of confidence, right? It's a confidence game because you don't see the answer options. You need to be confident about the answer that you got. That's very important. All right, that's also a kind of testing your confidence levels. All right, fair enough. Let's come back to this. How many natural numbers less than 200 have even number of factors? Now, finding even number of factors is very, very difficult, right? Finding even number of factors is very difficult. Rather, what do I do? Total number of numbers. So how do I approach this particular question is, my answer is a total numbers. How many numbers are there? Which means what is my sample size? What is my population? Population is a statistical word, right? Sample size. Let's keep it simple, right? Total number of numbers minus number of numbers which have odd factors. All right, which total number of numbers and number of numbers which have odd number of factors, numbers having odd factors. So that gives me the numbers, count of numbers having even number of factors, or an even number of factors. This is the better way to deal with this particular question. Why? Because finding the number of numbers with odd factors is always easy, right? Hey, what is the total number of numbers? Less than 200. That's what he's saying, that how many natural numbers less than 200, which means 199. Okay, sometimes people make this mistake also. They will write 200 here. Happily, they will write 200. They will see this number 200. They will read it. There are some words which came before that. It says that less than 200. We need to be mindful about our sample size. All right, so which implies that it is not 200. Our sample size is 199. That is 1, 2, 3 up to 199. This is my sample size, right? 199 numbers. Okay, minus number of numbers having the odd factors. Which are the numbers which have the odd factors? We said that the numbers having odd factors are the numbers which are perfect squares. Okay, perfect squares up to 200, which we will all know, right? Yeah, so because all it knows, so you might have heard already. If not, you should know the squares of the numbers till 25 at least. That is, you should know 1 square, you should know 2 square, you should know 3 square. Like this, you should know 25 square, which is 625. Till here, you are supposed to be knowing the squares. It's not just about how do I calculate those squares. You must know those squares as well by heart, memory, right? Yeah. Nevertheless, therefore, since you know up to 625, 200 is not a big deal. Assuming that we know very comfortably up to 625, I can recognize all squares. Then what's the problem? You can easily recognize till 200, right? Nevertheless, okay. Nevertheless, what do you say here? 1 square is less than 200, 2 square is less than 200, 3 square is less than 200. Should I write all of them? No, not required. Think about this. Which square will you write less than this? You would say that, okay, you will be writing 14 square. What is 14 square? 196. You stop there. In the sense, when you look at all the numbers here, you will come across 1 square in this range, you will come across 2 square in this range, you will come across 3 square in this range. In the sense, 9 you come across. Right? What is the largest number you come across? 14 square, which is nothing but 196, right? So you come across 1, 4, 9, like this up to 196, which is 14 squares. And hence you are saying that, man, I will subtract 14 numbers which are not in my favor. Together I have 199 observations. No, it is not 200, right? Less than 200 means what? Up to 199, okay, out of which, right now the numbers having the odd factors are 14. Reduce this number 14, and hence you say that 185 numbers less than 200 have even number of factors, right? Even number of factors. Fair enough. Let me say the same question. If I ask you the same question, how many natural numbers less than 200 have exactly 3 factors? Just instead of having this even number of factors, if I just cut this off, right? Even number of factors, if I cut it off and if I introduce the statement here saying that, hey, how many natural numbers less than 200 have exactly 3 factors, right? They have exactly 3 factors. Right, so what did we discuss there? The numbers having exactly 3 factors are the numbers which are of the form. The number should be of the form a square of a prime number, right? Square of a prime number. Now I know this list 1 to 14, right? Because less than 200 means I will want to. We already discussed that 1 square to 14 square. Hey, which numbers come into the picture? 2 square comes in the picture. 2, 3, up to 14. Fine, list out the primes. 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime, 11 is a prime, and 13 is a prime. Of course, the square of these numbers I'm talking about. So these are the numbers. 4 is a number, right? 9 is a number, 25 is a number, like this 169 is a number, which are all less than 200. And then you say that, hey, there are only 6 such numbers, right? In this case, my answer would have been 6. There are 6 numbers which are less than 200, but they have exactly 3 factors, right? Yeah. So that puts the perspective about my 3 points that I tried to make, right? I made about 3 points there. So now this kind of puts my summary to perspective on this particular question. Good enough. Let's take a look at this particular number. Right, let's take a look at this number. So take about a 30 seconds time and reflect. How do you go about this? How many 3-digit natural numbers have exactly 3 factors? Go about, think about it for about 30 seconds maybe. You think about it. And if you get any answer, you can plug it in the chat. Otherwise, we'll discuss after 30 seconds. Yeah, okay. 3-digit natural numbers have exactly 3 factors. First of all, right, anything that is having odd number of factors is a perfect square. So you understand that, man, you are looking for the perfect squares between 100, because 3-digit numbers 100 and 999. You are looking the numbers of the form which are of the square of a prime number. That your number should be of the form of square of a prime number. You are looking for such numbers because they are the ones which have the perfect square. Now, even before you look at the square of a prime number, try and look at what are the perfect square which come between this. You understand that 10 square is there. What is the 10 square? 100. Then you have 11 square which comes into this particular range, right? 11 square, already you say that, that is 121. and so on. Okay, till where? All right, now 999. You understand that, man. 31 square also I can talk about, which becomes 961, because you have a benchmark number. All right, this is the benchmark number. What is the benchmark number? 32 square, which is equal to 1024, which is also called as 1 kilobyte, right? 1 KB. Right, those are in the digital language, it's also 1 KB, or 1024 is also nothing but 2 raised to power 10. There are many multiple ways to remember this beautiful number. 1024 is the smallest 4-digit number, which is a perfect square. Firstly, it's the smallest 4-digit number, which is a perfect square. It's also nothing but 32 square, right? It's also called as 2 raised to power 10. Those who are using the binaries, you understand that it's nothing but 2 raised to power 10. All right, it's also called as 1 kilobyte, right? Those who are into the those who are into the digital, all right, those who are into the digital world, that's your computer science, engineering, etc., you understand that that's also nothing but 1 kilobyte. Fair enough, right? That's a story behind 32, one of the beautiful numbers, and then in this particular question, when I asked you, hey, figure out the numbers between 100 to 999, you are looking at a perfect square lying between 100 and 999. Sure, all of the perfect squares, but it should also be of the form square of a prime number. Yeah, what is my sample size? Therefore, 10 square to 31 square. That is the first set of sample size. You will talk about 10 square, 11 square, 12 square, like this, up to 31 square. This is your sample size. Out of this sample size, 10 is discarded. Why? Because it's a composite number, right? 11 is included, 12 discarded, 13 included. In the sense, now you are trying to say that, hey, P can take a value of 11 or 13 or 17 or 19 or 23 or 29 or 31. Right, these are the values P can take, which are the prime numbers between 10 and 31 square. Of course, the square of them, and then you say that, hey, there are 7 such numbers. There are 7 3-digit numbers. Of course, but all lie between 100 and 999. Such a huge sample size. In that particular huge sample size, there are only 7 numbers, all of which have exactly 3 factors. Right, exactly 3 factors. Good enough, right? So this is what we try to kind of put the summary to this. What is that we try to discuss? The number, if there is a number n, the number of factors less than root n, right? If there are x factors less than root n, there will be x factors greater than root n. That is the first point that we kind of discussed. Point number 2, we said that if n is not a perfect square, it would have even number of factors, right? It has even number of factors. If n is a perfect square, then it has odd factors, right? It has odd number of factors. Right? It has odd number of factors. Under this, we also kind of discussed it further, saying that, hey, if the n is a square of a composite number, right, then it would have 5 or 7 or 9 or 11 or 13, this kind of factors. Instead, if this n is a square of a prime number, then it would have exactly 3 factors, right? This is, we try to do a couple of questions built around this particular concept, right? This is what we kind of try to discuss it out there. Yeah, quickly, some announcements, few announcements quickly. There is a batch which launched on 25th of December. That's a weekend morning batch. That's for CAT 22. And there are certain batches which are set to roll out day after tomorrow, in about 2 days from now. That's on 29th of December. Yeah, one for CAT and the other one for CMAT alone, right? That's only for the CMAT. CMAT is in the month of already a couple of months you have a CMAT. Already it's for that particular exam. Good. So what are these batches? When we call about these batches, I'll let know batch because we call it as a batch, right? We call them as the batch. What happens in a batch? It's nothing but having a structured course. Right, you will get certain notes. The faculty would have put solid. Now, if say for example, if you're looking at this percentiler batch, now these 3 faculty members might have put about a short video of 3 minutes or so as to trying to tell that if somebody is taking a quant here, are they starting from level 0 going to level 1 and then to level 2, or are they starting straight away at level 1 and level 2, or are they starting about then only impactful concepts? Likewise, because different people in different area would be at a different stage of learning. right? Different stage of learning. So based on that, you kind of figure out that, okay, which batch you should be kind of looking at. Multiple batches would be starting every week. There will be 1 or 2 batch launches, right? And you will pick up the batch which suits your requirement. However, you have access to all the batches, but you will kind of pick up the batch which makes sense to you. Right, good. And how do you become a part of this? To become a part of this, you may have to go for the subscription, right? So plus subscription. So there are 6-month subscriptions, 12-month subscription plan, 18-month subscription plan, 24-month subscription plan. Yes, on these subscription plans come with a nominal prices, right? All these subscription plans come with a nominal price, and with any of the educator code, if you use any of the educator code, you get 10% discount on these particular subscriptions. 10% discount implies that maybe about 15,000 on this. After getting a 10% discount, you can free to use my educator code as well, which is Belvi 100. Belvi 100 doesn't mean that you get 100% discount. It's a Belvi 100, but then you still get about 10% discount there. But my preference has been on this is always going for the iconic subscription. Iconic subscription gives you access to the structured courses, no doubt about it. But in addition to that, you will be getting 25 one-to-one mentoring sessions with a mentor of your choice, right? Yeah. So with a mentor of your choice, you'll be getting 25 one-to-one sessions as well. Yeah. Yes. Someone is trying to, RY, you are trying to ask. Yes, it's a new batch. That's right. Yeah. Okay, you will be getting 25 one-to-one sessions as well. Okay, so what I meant by 25 one-to-one sessions, you can set up the agenda for these 25 sessions. You see, technically 6 months has about 26 weeks, right? 26 weeks roughly. 6 months has about 26 weeks. You get 25 one-to-one meetings, in the sense you can set up a meeting most likely every single week, and then you can discuss with whatever the agenda for that particular week. For example, one of the agenda could be what should be my preparation calendar for the month of Jan. Right, then you other agenda, it could be, okay, so how should I, this is my profile, this is my background on Quant, how should I approach Quant, how should I approach verbal, right? Or it could be like, sometimes when the testing season comes, it could be about, hey, how should I approach the test, or now in the sense like, so based on your based on the inputs that you got so far, so how, based on the inputs, so what is my SWOT, so how should I look at each section there? At some stage of the test, you will say that how do I improve my scores then, right? Different requirements at different stages. That is what you mean by getting one-to-ones, right? That's what the kind of things you can discuss in one-to-ones, in addition to doubts, in addition to concepts, all of that, right? Similarly, 12-month subscription would have 50 one-to-one facilities, 24-month subscription 100 one-to-ones. See, I always believe that these one-to-ones would be a big help. Right, honestly, these one-to-ones are going to be a big help. That will always give a push, because each individual is little different when it comes to the learning perspective based on their 20 years of pedigree, right? So therefore, it's always good to have this one-to-one mentoring sessions, one-to-one discussions of your choice rather than our choice. It's always going to be your choice. Okay, so but then there is an offer now. So in a 6 months offer, not 25, so there is an offer, you get 35 one-to-ones. In a 12 months, that's a 1 year, instead of 50, you are getting 70 one-to-ones, so on, in the sense you are getting 40% more than what it is supposed to be during this offer period, right? That's one of the things that is happening. All right, now let me come to the second point of my discussion. So then I will wrap this up, the second point, completely maybe in tomorrow's lecture, but let me give a start to the second point. We did the first part of the discussion. Let me quickly illustrate the second part of the discussion, which is the fundamental theorem of arithmetic, which you guys would have done in the high school, right? That are fundamental principles of arithmetic. Some people would have wrote this as FTA, or some people would have write this as FPA. Doesn't matter which way your teachers have taught this, FTA or FPA. Okay, what we are doing in this foundation is we are trying to look and consolidate our learning still high school very clearly before we unleash ourselves into the intermediate stage of learning, right? Yeah. So your teachers might have said this, yeah, what is this FTA or FPA, right? If you remember that definition, you know that, hey, it is resolving a composite number into primes, right? It is resolving a composite number into primes. For example, when I look at 18, I understand that 18 is 2 power 1 into 3 raised to power 2. Now before this you would have written this 2 into 3 into 3, and then you break it up and you say that a 3 into 3 can also be written as 3 square, right? That is what you mean by FTA, or it's also called as FPA. Which way you use it doesn't really matter. Okay, for example, similarly when I look at this when I look at 72, how do I go about this? Your teachers might have taught like this. Hey, look at this, take a smallest prime number, therefore you say that 736 times, all right, then 2, all right, now then you say that 2 18 times, then you say 2 9 times, then you say 3 3 times. Say 3 is a prime number, stop it, therefore 2 into 2 into 2, you say that it is 2 cube, and then you say that a 3 into 3, all right, which is nothing but 3 square. Now this is called as FTA, fundamental theorem of arithmetic, or fundamental principle of arithmetic, right? What is that? Any composite number can be resolved into primes like this. Then you would have written a general form saying that, hey, any composite number n can be written as prime 1 raised to power a, prime 2 raised to power b, prime 3 raised to power c, and so on, right? This is what you kind of learn. For example, in this particular example, what do you mean by this 72? So if you say that my n is 72, this is 2 raised to power 3, the prime is 2, which is considered 3 times. There is another prime 3 which got considered 2 times, right? Which got considered 2 times. Fair enough. Okay, why are we doing this? That's the next question. Okay, why we are doing FTA as a part of right, FTA as a part of this study, right? Part of this factor study. Simple reason. The reason being, okay, I will count the factors from here as well. For example, if I know that 72 is nothing but this, right? I can apply on FTA. I can apply now I can apply the fundamental principle of counting to count the factors quickly, because in the exam we will get the factors like 7200, etc. Tell me how many factors are there. I can't be going by the method that I learned earlier in the beginning of this particular class. A root of 7200, half of the factors come before, half of the factors come after, I will start figuring them out. No, that's not the way to do that, right? What you do is, hey, you look at this 7200, you do FTA on that, and then you do FPA on that. From FTA you will come to FPA, and you will give the count of the factors very quickly, right? You give the kind of count of the factors very quickly. All right, let us understand this. So what is the meaning of this? So when you write that, hey, 72 can be written as, let me take this to illustrate my point. 72 can be written as 2 raised to power 3 and 3 raised to power 2 implies 2 power 0 divides 72, 2 power 0 divides 72, 2 power 1 divides 72, 2 power 2 also divides 72, 2 power 3 also divides 72, 2 power 4 does not divide 72. Why? Because 2 raised to power 3 is the highest, right? Therefore 2 power 4 does not divide. Similarly 3 power, right? 3 power 0, what is 3 power 0? 1 divides 72, that will divide. 3 power 1 divides 72, 3 power 1 divides 72, 3 power 2 divides 72, because I have 3 power 2, 3 power 3 does not divide 70. Good. All right, that's a point we are kind of trying to make. And the FCA says that in the sense, all right, now therefore if you look at this, hey, how many ways? All right, this can be dealt in 4 ways. This can be dealt in 3 ways. 4 into 3, therefore you say that there are 12 factors for this particular number, which means 72 has 12 factors. Now you may suddenly wonder, hang on sir, how you are doing this? All right, now there is a 2 power 0, 2 power 1, 2 power 2, 4, and then 3 power 0, 3 power 1, 3 power 2, 3. Correct. Why I should multiply this, just in case if you have the doubt. Well, that comes from fundamental principles of counting. What is this fundamental principle of counting? Let me quickly illustrate that point as well, because these are very fundamental principles. Just like you did FPA on 70 to arrive at this. Once you arrived at this particular number, to arrive at this, to arrive at this 12, you did FPC, right? From FPA you did FPC. Hey, what is this FPC? Just like the way I explained FPA, allow me to explain this FPC also to you. For example, let me take this 72. So this is what you mean. Okay, you said let me list down these particular numbers here. Let me list down in the column. 2 power 0, 2 power 1, 2 power 2, 2 power 3. You are trying to say that 2 power 0 divides 72, 2 power 1 divides 72, 2 power 2 divides 72, 2 power 3 divides 72. Good, very good. And all right, now on the row side, let me write this on the row side. 3 power 0, 3 power 1, 3 power 2. All right. 3 power 1 divides 72, 3 power 2 divides 72, 3 power 0 divides 72, 3 power 1 and 3 power 2 also divides 72. Fair enough, right? So, and the combination of these cells also divide that. That is my point. Okay. So now I'm generating factors. Now look, I'm now writing the factors of 72. I'm writing all the factors of 72. Half, right? 3 power 0 into 2, 3, 2 power 0, 1. Because 3 power 0 is 1, 1 into 1 is 1. Second one, 3 power 0 into 2 power 1, that is 1 into 2. All it nothing but 2. 2 is also a factor. Okay? 3 power 0 into 2 power 2, that is 1 into 4. That 4 is also a factor. Good. Alright. So 3 power 0 into 2 raised to power 3, that is 8 into 3. Alright, which is nothing but 24. That is also a factor. Likewise, 3 power 0 into 2 raised to power 1. This cell definition, I'm writing this cell definition, which means row and column, right? So here this row and this column, I multiply these two to write this particular number, right? So therefore 1 into 3, this is going to be 3. Let me write, allow me to write the numbers quickly there, right? That is 6. And then similarly, if you want to understand this number and this particular number, that is 3 and 4, all right, which is going to be 12 out here, right? And then similarly, all right, this is going to be, all right, sorry, this is, all right, this particular number is 8, therefore 8 into 3, 24. Right. Okay. Now similarly, if I were to write here something, so I need to multiply these two folks and write it here. That is 9 into 1, which is going to be 9. Here 9, and then there is 1, 2, all right, which is going to be 18. Right. Here it is going to be 4, and here it is 9, which is 36. Similarly, the last one is 72. Are there 12 numbers here? Yes. Check it out. All right. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. These are the 12 factors I was talking about. When you got these 12 factors here, when you said I have 12 factors, now this is the 12 that I am talking about, right? Okay, so how did I generate this? How did I generate this? Now think about this 4. What is this 4 stands for? 4 columns. Say, where are the 4 columns, man? 2 power 0 is a column, 2 power 1 is a column, 2 power 2 is a column, 2 power 3 is a column, which means it can be permuted in 4 ways, combination, right? And then rows, where did I write these 3 numbers? That is 3 power 0, 3 power 1, 3 power 2. What do you mean by 3? So here, first row, there is a second row, and there is a third row. Now, how many cells I got? Hey, if you have 3 rows and 4 columns, how many cells you will have? All right, you would be having in that case, right? You would be having 12 cells, right? You will be having 12 cells here, right? You would be having 12 cells, and that is what I kind of wrote there. These 12 cells means 12 factors, right? I hope you are getting this, what I'm trying to say here. Another way to represent this particular thought, if you have understood this, I'll tell another way to represent this particular thought. For example, hey, you have 2 raised to power 3, right? 2 raised to power 3. Print 2's on 3 cards. 2, 2 and 2. I took a card on which I printed a 2. I took 3 cards. On each of the cards I printed a 2. Right. Then I took another 2 cards on which I printed a 3. I took another 2 cards on which I printed a 3. I printed a 3. Now, so how many ways you can deal with this? Now listen to this. All right, how many ways you can deal with this? You may say that, hey, I will give no card of 2, no 2. You may say that, no sir, I will give 1 card on which 2 is printed, 1 card on which 2 is printed. You may say that I will give 2 cards on which 2 is printed. I will hand over 3 cards on which 2 is printed. In the sense, this can be dealt in, which means 3 cards of 2's can be dealt in 4 ways. 3 cards on which 2 is printed can be dealt in 4 ways. What do you mean? Assume that you are sitting there on the other side. I am here. So now you have 3 cards on which 2 is printed. Hey, why 3 cards on which 2 is printed? Because 2 raised to power 3. Print 3 cards on which 2 is printed. How many ways you can give those cards to me? Only cards on which 2 is printed. You will say that I will not give any cards of 2 because I want it. Fair enough, keep it to yourself. Or you may say that, okay, I will give 1 card. Alright, yeah, 1 card. Or you may say that, no, I will give 2 cards. Fair enough. I will give 3 cards. Fair enough. Which means you can deal with it in 4 ways. 4 decision parameters are possible. Right? Similarly, when you look at these 3's, right? Now you may say that, no, I will not give any 3 to you. Fair enough. Or I will give 1 card on which 3 is printed. Or I will give both cards on which 3 is printed. How many decisions can be made here? 3 ways. Which means 3 decisions can be made. Now put both the bins together. Put them together. 4 ways of doing the decisions on 2's and 3 ways of doing the decision on 3's. Therefore, 4 into 3 is also nothing but 12. Okay, I took 2 different ways to explain fundamental principle of counting for these factors, right? I explained 2 different ways. One, as I said that, okay, print the cards and try doing that. The other, I tried to do it in a little mathematical grid particular fashion. Whichever way you understood, it really doesn't matter. So summary I'm writing here. Any composite number n, if it can be written as prime 1 raised to power a, and prime 2 raised to power b and prime 3 raised to power c. Alright, then you say that, hey, number of factors of the number of factors of this particular composite number n is nothing but a plus 1. Why a plus 1? Now look at this. When it was 2 raised to power 3, you went on to write 4 there. That is what you mean by the power is 3, but you wrote 3 plus 1, right? Therefore you wrote 1 there. Similarly, you look at this b and you will write it as b plus 1. Alright, b plus 1, like here, hey, the power was 2, but you went on to record 3 here because there is a 3 power 0 as well, right? And then the power is c. Alright, you will see, write it as c plus 1 as well. This is number of ways of finding the factors of this particular number. Good. So this is the first learning that I wanted you to understand from the factors perspective, which you will learn kind of in a high school. Sometimes based on the boards, you might have learned in the 11th standard as well. Depends, right? Whether you learned during around 9th or 10th, or you learned about 11th, depends on which board already that you kind of studied there, right? That's the kind of you studied there. Yeah, we will do one simple question right now. So I hope you kind of noted this down in your mind and this recall, and let's do one simple question before we kind of wind up for today, and we'll continue the discussion tomorrow on these particular factors. All right, let's take a look at this. Let the number n be 7200. Find the number of 3 questions, number of factors, prime factors and composite factors, right? 3 questions, right? 3 questions out here. Let's take a look at this particular question, right? Let's take a look at this. 7200. First of all, you got to take a look at your n, and you must be writing it as prime 1 raised to power a, prime 2 raised to power b, and so on and so forth, right? You need to first segregate them, which is very important. Hey, how do I write this? 7200. Quickly in your mind, you can call this as 72 into 100. Hey, what is 72? 72 is nothing but 2 raised to power 3 and 3 raised to power 2. Hey, what is 100, man? 100 is nothing but 2 raised to power 2 into 5 raised to power 2. Bring the 2's together, it will ultimately become 2 raised to power 5 and 3 raised to power 2 and 5 raised to power 2. Good. And hence you are saying that, hey, my 7200 is nothing but 2 raised to power 5, 3 raised to power 2 and 5 raised to power 2. Okay, don't worry, as you start working on this, all right, this is nothing but FTC, fundamental theorem of FTA, fundamental theorem of arithmetic, on this particular number. So this is how it looks. So writing this is not a big deal. These things keep happening in the mind after some time. I just showed you how you can quickly break it in your mind technically there. That's all I meant. Okay, now you wrote this 7200, you broke it and you kind of made this into prime, decompose. Already you wrote them in terms of primes. Good. Now number of factors of n. So we learned about that, right? Number of factors of 7200. Only count. What did we say? If there is 2 raised to power 5, I can deal with this in 5 plus 1 ways. Right? If it is 2, I can deal with this in 2 plus 1 ways. If it is 2 or at your power, then I can deal with this in another 2 plus 1 ways. I explained already very clearly there. Therefore 6 into 3 into 3, right? Therefore you will say that 54 factors is what this particular number has, right? This particular number has 54 factors, right? Good. Hey, how many prime factors are there for this particular number? By the way, the number of prime factors are only 3, right? Number of prime factors are only 3. You may wonder, hey, which are the 3 prime factors? 2, there is 3 and there is 5. That's it. Already if I were to list it here, 2 is one of the prime factors, 3 is a prime factor, 5 is a prime factor. Hey, 1 is not a prime factor, 1 is neither prime nor composite, right? So 1 is neither prime nor composite, and therefore a number of composite factors, what a lot of people do on the number of composite factors is total, that is 54, and they will subtract the prime factors and they will write it as 51, alright, which will be an incorrect answer option, right? Because quickly, alright, in a hurry, what people generally do is, out of the total factors, if the total factors are 54, they tend to believe that they are either going to be prime or they are going to be composite. No, please remember that 1 is a factor of every number which is neither prime nor composite, and hence what you do here is, hey, it is 54, correct, remove these 3 factors which are prime and remove another 1 factor, alright, which is neither prime nor composite. Which is that 1 factor? That is 1 itself, the number 1, which is neither prime nor composite, and hence you say that, hey, there are 50 factors which are composite in nature, right? Yeah, there are 50 composite factors in nature. Good. So you can go back to this particular video, just listen through this particular video once again, so that like your high school stuff, whatever you kind of learned in the high school, I kind of summarized. In the next lecture, I will come into the 11th standard, right? Because I said that a quant cat will have cat or quant of the cat would be, or it require your understanding of 11th and 12th standard math. Up to 11th and 12th standard, not everything, but bits and pieces of 11th and 12th standard maths is essential to crack the cat. All right, therefore I'll be revising few elements of that as well. Then we'll be kind of going deeper into that at the intermediate stage. Right, that sets an end to my discussion. Then I will take up the rest of it tomorrow. If by chance anybody here who are preparing for cat, appeared for cat 21, guys, I suggest that you kind of enroll for this particular program, right? That is the NBA champions, and based on your cat scores there will be a refund, right? There is a reward. All right, now there is a reward, get up to 10x of your subscription fee, which means if you are already a pre-subscriber, so you just now get register yourself for this MBA champions, and the top percentilers will get some reward up to 10 times of the fees that you kind of already paid, right? Subscription fee that you kind of paid. Yeah, that's bring me to the end of this particular discussion. Thank you for being here, right? If you have liked this particular video, or like it, or press on the like button before you leave, whether you are doing it online or offline, whenever you are doing it. If you like any portion of this particular video, you can leave a comment and you can like it. Yeah, and if you have any concerns meanwhile, right, if you have some concerns, you can always come back. You can use the Telegram channel, and you can reach out to me on the Telegram channel that I mentioned in the beginning of this particular lecture. You can reach me out there. Yeah, that's pretty much about what I wanted to convey today. I hope you enjoyed and you kind of learned through this particular discussion. I will see you in my next lecture. All right, bye till then. God bless you, and God bless you.